All right, welcome back, everybody. So we'll go ahead and pick up where we last left off. So went over in the last video the multi-area support for ISIS. So we'll go ahead and go over some additional ISIS info from a Cisco implementation standpoint. Each vendor has their own flavors of how they do it. Of course, it's based off of the RFC 1195, but this is going to be all based off of Cisco's implementation since I am studying for the CCIE Service Provider certification. The default administrative distance is 115, so OSPF routes are still going to be preferred over ISIS routes, and of course that is configurable. Supports LSPDB and RIB filtering. Supports authentication, both at level or area or level and area support. And with that being said, is if you have two, like we had that in the previous example, you can actually set a password on the area so that if router, let's go back to the example here, so that if router 5, if you put a password on area 2, and when router 5 or router 6 gets that information and doesn't have the password for it, he will not be able to form an adjacency with router 7 unless that password is matching. So you can do additional security features to make sure that you don't accidentally form an adjacency with a device that you're not supposed to be forming with. It is sent in plain text, so that's something to keep in mind. It doesn't encrypt the actual message of the packet, so if you have some kind of a sniffer or somebody sniffs that packet, that can actually see that password. It supports native route tagging, nonstop forwarding support, as I mentioned earlier. MPLS TE support with use of wide metric type. You have to have that enabled in order for that feature to be used. But if you want to do MPLS traffic engineering tunnels, that's something you can do with ISIS because it is a link state protocol. It's VRF aware. It supports fast convergence, multi-topology and single topology support for IPv6 and IPv4. So what that means is that you can actually have a single topology for both your IPv6 and IPv4 routes. And saying so that way you don't actually have to establish an IPv6 data plane in order to exchange IPv6 routes. You can still use the IPv4 based topology and exchange both prefixes and vice versa. The most recommended implementation is do multi-topology support, and that also differs between the defaults with Cisco devices, ESXi being an example. Um, so the most recommended configuration for that is going to be the multi-topology support. Supports bidirectional forward detection, and then supports equal cost multipathing for routes that have the same metric number. You'll be able to do multi exit points for any prefix that's learned through ISIS. And it supports fast reroute. Essentially, you're able to have a backup route that's sitting in the ISIS RIB, and in case a failure happens on the primary path, it'll automatically be on standby to add that route inside the routing table for the device to be used for forwarding without any reconvergence having to happen between the link state database. Some helpful commands that I came across that I got from the actual Cisco command reference for ISIS that I feel like should be in your arsenal and for troubleshooting purposes and also for verification of your ISIS neighbors. And these are going to vary for ESXi. Like I said, I am studying for the service provider, so I use both set of commands, but for the most part, most people are going to be coming from the enterprise environment. Uh, and with this protocol as well, this is more of a service provider protocol, but if you have a service provider network and you're using, the ASR 1000s, this will be what you'll be using for your show commands. ESXi is pretty much the same. There is some backwards compatibility, but for the most part, this is all going to be just focused in on ESXi. So the show ISIS neighbor command displays the ISIS neighbors, of course. You have your show CLNS interface, which shows the CLNS interface specific information. Show ISIS database, which shows the contents of the link state database. The show ISIS rib, which actually gives you the contents of the ISIS routing table, which is different from when you do the show IP route, which is the actual global routing table from the router. This actually gives you the routing table from the ISIS process once the link state database has been converged in all the available paths that ISIS has learned for each given prefix. The shell ISIS hostname. So it displays the host name of the associated ISIS circuit ID, and that comes into play whenever you're doing the show ISIS neighbor. It sometimes doesn't give you the well, I can't remember off the top, but for the most part, the host name of the router doesn't exist in that command output. It'll see the circuit ID, but sometimes that's not too straightforward. With the show ISIS host name, it'll actually show you what the host name of your neighboring system is and the circuit ID that's associated with it. So that's pretty helpful in some troubleshooting situations where you have a very large broadcast network or multi-access network. The show ISIS LSP log, which displays the log for the link state information and the triggered events. And so the iOS command reference actually gives you a list of triggers, a long list of triggers actually, but these are some of the more common ones that you'll see. You have your del adjacency, which is the adjacency went down, your new adjacency, which means your adjacency went up, your DIS, the DIS, which means the pseudo node has changed, or your DIS, your designated intermediate system has changed. Config generated something in the configuration has changed that caused the LSP to reconverge, or the link state database to reconverge, and then the clear. Some form of the manual clear command was used. So if you're doing a show clear, or if you're doing a clear ISIS neighbors, clear ISIS rib, this trigger will actually show that in the LSP log. So it's one of those things that Cisco would love to kind of get you on and throw one of those, if depending on this output, what has happened in the ISIS control plane. So some of these triggers, there's a long list of them, but there's some of them that would jump out to be something that would be very common, and these are the ones that I see mainly, especially as I'm going through my labs or doing some testing of my own. The show ISIS SPF log. It displays how often and why the routers run the SPF calculation. And some of the common triggers are the database has changed. So it uses the clear, somebody did a clear ISIS colon or star command, which means that you're actually clearing the ISIS process altogether, which makes the control plane reconverge, which forces the SPF tree to get rebuilt. The IP query, if somebody does a clear IP route command on the router, that means the routing table has been flushed, and whatever the participating protocols need to re-inject those routes, that IP query trigger will show, and I'll actually let you know that has occurred. New metric was configured on the router, meaning that if somebody goes and adjusts the metric for an interface or adjusts a metric for for a route, it'll actually show that the SPF was reran to make the correct adjustments to reflect that. And then new LSP means a new router or a pseudo node has appeared in the topology. And you'll see that if in a situation where you lose your DIS and a new DIS has been elected, or you add another router and change the priority on the interface, forcing that router to become the new DIS, that trigger would actually show there. So that was just some of the my presentation that I had for it. We'll go in and look at some packets in another video here, just to give you guys another glimpse of what it looks like after doing the packet captures, and do some show commands on the routers, on the topology that I have configured here, just so you guys can get a better idea on what the ISIS configuration looks like.